Again. All right. Hi, my name's Clayton Kelly. I'm here with my friend Andrew Ricci. And I'm going to be helping you guys out with some math exam answers.
Oh, yeah.
The question I'm looking at today is from the November 2009 exam, paper 1, question 8, parts A and B. So let's start with reading the question aloud. In a class of 100 boys, 55 boys play football and 75 boys play rugby. Each boy must play at least one sport from football and rugby. Rather athletic. A. Find the number of boys who play both sports and write down the number of boys who play only rugby. B. One boy is selected at random. Find the probability that he plays only one sport, and given that the boy selected plays only one sport, find the probability that he plays rugby. This is a rather straightforward probability question, so let's get into it. Alright, so part 1 of A. We have to use the formula. The question is find the number of boys who play both sports. So we have to use the formula. The probability of A union B equals probability of A plus P of B minus the intersect of P, A, and B. So to substitute numbers into this formula for this equation, we put 100 for the total number of boys who play sports, and then for P of A and P and B we put 55 and 75 for the amount of boys playing football and rugby respectively, and then we subtract that by the unknown, which is the amount of boys who play both sports. So by doing some simple algebra, we can see the number of boys who play both sports is 30. Moving on to part 2 of A, the question is write down the number of boys who play only rugby. So to find this is some more simple algebra. We'll use R to represent the number of boys who play only rugby. So if 75 boys play rugby, but also might play some other sports, we do 75 minus the intersect value that we just found in part A. So 75 minus 30 equals 45. So the number of boys who only play rugby is 45. Moving on to part B of question 8. One boy selected at random. Find the probability that he plays only one sport. So we found in the previous question that 45 boys play rugby exclusively. So now we have to find the number of boys who play football, and that's pretty simple algebra. 55 minus 30 equals 25. So 25 boys play only football. Now, in order to find the probability of one boy who would be able to play, who's selected at random, playing one sport, we can see that 45 plus 25 equals 70. So that's the total number of boys who play one sport, and 70 divided by 100 can be reduced to 7 over 10 or 70%. Therefore, the probability that a random boy selected plays only one sport is 70%, or 7 over 10. The last part of the question, part 2 of B, is given that the boy selected plays only one sport, finds the probability that he plays rugby. Find the probability that he plays rugby. So here we have to use the formula, a new formula, which is the probability of A given B equals the probability of A intersect B divided by P of B. So let's just sub in our variables that we found in previous questions. The probability of A will be, the given variable is the amount of rugby players, amount of kids who play both sports, and we know this is 70, so we can substitute 70 in for P of B. And as we found out in the first question up here, the intersect of P, A, and B is 30. So just plug that in simply and you get 30 divided by 70 and reduce that to 3 over 7. So given that a boy selected plays only one sport, the probability that he plays rugby is 3 over 7. Thank you very much and good luck studying, everyone. Alright, where am I looking for here? Oh yeah.